So welcome to another session of Everyday Mathematics. Today's problem is problem 19 of the MIT 2024 Integration B regular season. And that is the definite integral from x equals to 1 to x tending to infinity of e to the power x plus x times e to the power x all over x squared times e to the power 2x minus 1. This is an interesting problem, but all the same, easy to solve. I'd like to thank our subscribers. Your support means a lot. We appreciate your support. Please continue to support us by liking what we share and also leaving comments and words of support. That would mean a lot. To our first-time visitors here at Everyday Mathematics, what we do is we go about and around, we look at interesting problems, we try to solve them. When we get solutions, we share with you. For those of us who are coming back again but haven't subscribed, we do really encourage you to subscribe to our channel. So this problem is interesting, as I said, but not very hard. So the first thing that I usually would be kind of interested in is I look at the denominator here and I see a square. And that means that I could use the difference of two squares and the sum of two squares idea. When you multiply them, then you do have an expression like this, since 1 is 1 squared. So I've decided to bunch these together. So we have x times e to the power x here, the denominator, square. And since we know that a squared minus b squared is equals to, in brackets, a minus b close bracket times a plus b, right? So this difference of two squares, a squared is this term here, and b squared is 1 squared here. So we can now express this as e to the power x plus x times e to the power x over x times e to the power x plus 1, the sum part here, yeah, and times x times e to the power x minus 1, and that is this, right? Now, we can now go ahead and express this as a partial fraction. Now we do that ignoring the numerator. The denominator, 1 over the denominator is the same as 1 over x times e to the power x minus 1 minus 1 over x times e to the power x plus 1 times a half. Because when you combine this, you have a 2 in the numerator, and to cancel that 2, we have a half here. Then now, multiplying this numerator across, we have half times the integral from x equals to 1 to x tending to infinity of e to the power x plus x to the plus x times e to the power x over x times e to the power x minus 1 minus x e to the power x plus x times e to the power x over x times e to the power x plus 1. Now, when I look at these here, this is the same as the derivative of, right? X times e to the power x, right? That's the same thing, because when you use the derivative of a product, pass away, differentiate x and multiply by ex, so the x goes away, you have x here, and then x times the derivative of e to the power x, the derivative of e to the power x is the same as e to the power x, so this is what we have. But as we look at the denominator, we see that there's a difference here. There's a minus 1, and this is a constant. So this is the same as the derivative of x e to the power x minus 1. Same thing. And the same thing on this side, this is the same as the derivative of e, x times e to the power x plus 1. And so we can go ahead and say, okay, here, the numerator is the derivative of the denominator. The same thing here, the numerator is the derivative of the denominator. So that means that when we integrate it, this is the same as the natural logarithm, half times the natural logarithm of x times e to the power x minus 1 minus the natural logarithm of x times e to the power x plus 1, right? So the next thing is using the rules of logarithms. When you have the difference of two log functions, that's the same as the log function of the quotient of whatever is under the log functions, okay? And so we have x times e to the power x minus 1 over x times e to the power x plus 1. Now, because I have an infinity here, I like to express it inside this expression in such a way that when I get a limit as x tends to infinity, I have something that is finite. So what I do is I divide both sides by x to the power ex so that I have 1 minus x to the power negative x over 1 plus e to the power negative x over x, all that under the log function, such that when x tends to infinity on the upper side, the numerator here tends to 0, and then 0 times 0 because 1 over x also tends to 0. And so what we get here is that on the upper limit as x tends to infinity, this part here tends to 1 over 1 minus limit as x tends to 1, we have 1 minus e to the power negative 1 over 1 plus 1 over 1 plus e to the power negative 1 over 1. And so log 1 minus 0, 1 plus 0, minus log 1 minus e to the power negative 1 over 1 plus e to the power negative 1. So the e to the power negative 1 is the same as 1 over e, multiply across by e, and we get, since log 1 here from here is 0, so that goes away. And here we have minus log e minus 1 over e plus 1. The negative here can go up here as power negative 1, right? And that means that we get the reciprocal of whatever is under the log function. And so we have half natural log of e plus 1 over e minus 1. And that is the answer. Thank you so much for tuning in. We do appreciate your support. Means a lot. If you haven't subscribed, please press the subscribe button. We'll love your support. Share, comment. Your support would mean a lot. Thank you. Until next time, be blessed.